and ask. So a lot of times people will ask about certification. So when do you really need to get a certified test? You really need to get a certified test if you're meeting some sort of regulatory requirement, whether it's a federal requirement under the EPA Safe Drinking Water Act or a state requirement. There's also local county requirements, township requirements. So anytime you're meeting a requirement, you're going to need a certified laboratory, which means you will be doing a certified analysis. Anytime your client may need to use these results in terms of litigation, you want to have a certified analysis. So a lot of times with the gas drilling that was going on up in, well, Pennsylvania and Ohio, Marcellus Shale, where people were trying to establish a safe baseline of what their water quality was, those tests needed to be certified because they could potentially be used in litigation in the future. Other options, sometimes informational tests that are out there, detection levels are too high. They're not getting low enough to where you need to be. That's when you might want to seek a certified analysis. So let's talk a little bit about informational testing. Informational testing is testing that doesn't necessarily meet all the requirements of the certified testing. There's a lot of paperwork and requirements that are involved when you do certification. A lot of paperwork involved, but informational testing is a great way to get a nice water quality analysis without spending a lot of money. The informational testing, they're run on the same instrumentation that you use for certified testing. So ICP-MS for metals analysis, IC for inorganics, GCMS for volatiles. Those are some of the other HPLC and LCMS-MS. Those are highly sophisticated instruments that will yield accurate results. A lot more accurate than what you might find in your field test kits where you're using drops and looking for a color change. Informational tests will follow these approved methods. Some will have modifications to them, but the biggest advantage to using an informational test versus a certified test is there's a much lower cost involved. And it's a nice way for people to actually get a good idea of what their water quality is without spending a huge fortune. Again, there's a higher level of accuracy than a lot of these field tests that you guys might use, just because there's a lot of interferences with field test kits that you may not be aware of, whereas laboratories are more familiar with these types of interferences and they have built-in modifications to alleviate the interference so that you do end up with an accurate result. So sampler requirements, when you're sampling for public water supplies, there's a couple of requirements. Usually it's a state certified operator license that you are required to have. Some states have other state sampler requirements. I believe like the state of Maryland has its own requirements specifically for samplers. And then of course, laboratories that are certified in that state are also approved to collect those samples. When you're collecting samples for private wells, again, it's the state certified operators are totally approved to collect that. State certifications, certified laboratories. But when you're collecting on private wells, it all depends on what it is that you're collecting for. You want somebody who's trained and knows what they're doing when they're collecting these samples. And sometimes it doesn't necessarily, that state certified operator is used to collecting samples for public water supplies and not necessarily private wells. So it's best to look for somebody who has experience in collecting those samples for private wells. So we'll talk a little bit about laboratory certification. I get a lot of questions about, is your lab EPA certified? Well, the EPA doesn't actually certify laboratories. I should say they don't certify laboratories. They only certify labs under two programs. They will certify labs that do cryptosporidium testing. That's under the, I believe it's the groundwater rule. and then the UCMR. And the UCMR is the Unregulated Contaminant Monitoring Rule. Um, it's a program that the EPA has developed under the Safe Drinking Water Act to take a look at different contaminants that might be present in water, um, for possible future regulations. So the next one that's coming up, it's called the UCMR 5. And one of the big inclusions of the UCMR 5 is they're going to be looking at more of these PFAS chemicals, or the forever chemicals that we're all hearing about. So when you're talking about labs and certifications, there's a couple of different ways that labs get certified. There's what we call direct certification, where we go directly to the state that you're located in and you apply for your certification. There's reciprocal certification, where you get your certification from your state and you say, well, let's just say you're in Virginia, you have your certification through the state of Virginia, but you also want to test in Maryland. So you go to Maryland, you say, hey, I've got my certification in Virginia, will you accept this? Maryland will either say they accept it, and they'll give you reciprocal certification based on that direct state certification. Of course, you're going to have to pay them your fee, but there's a couple of catches with that. Just because every state's a little bit different in terms of how they regulate, some states will certify for everything. Some states will only certify for primary contaminants. Some states will, not certify for those secondary contaminants, the ones that are, not necessarily regulated under the federal guidelines. So if you have a state that you go to and they certify for just the primaries, and then you go to a reciprocal state and they certify for both, you don't have that certification for those secondary contaminants. So you could run into some issues there. If you have questions about that, certainly ask the lab that you're dealing with. Secondly, or I should say fourth, there is what we call NELAP accreditation. NELAP accreditation came about for this very reason. They wanted an easy way for labs to get multiple state certifications, follow the same guidelines. Unfortunately, not all 50 states said, yay, we're going to participate in this. I think we're up to like 15 states that participate in this. But what's nice about that is once you have that NELAP accreditation, you can apply to any of the NELAP states and your certification goes across all of those states. And you don't have that problem where you might be missing a couple of items because the first state that you have certification in offers it and the second one doesn't. So NELAP accreditation is good, except not all states will accept it. And then there is also categories of certification. So there's the Safe Drinking Water Act, where we're testing drinking water. This is typically where we're going to follow the regulations for when you're testing private wells. Is also, there's the Clean Water Act. This is usually for more of like rivers and surface waters. The Clean Air Act, underground storage tanks, and then Resource Conservation and Recovery Program, that's hazardous waste. So there's different certifications that when you're applying to the state, you have to say, I'm applying for the safe drinking water, or I'm applying for clean water, or I want to test for air. Excuse me. Then there's also what are called approved methods. So there's all kinds of methods that are out there to that basically tell you exactly what you're going to do to run the analysis. So the EPA provides a lot of these. There's different methods available on their website. And then there's also what are called standard methods. Those are basically for drinking water and wastewater. And then there's ASTM methods and USGS service methods. But I'm going to say most of the methods that you're going to run across in terms of testing drinking water are going to be EPA approved or those standard methods. So, chain of custody. Um, Chain of custody is really important, especially when you're dealing with certified testing. It's just basically a chronological record of who's been in possession of those samples and what analysis is going to be performed on them. This is especially critical when you're doing testing for litigation, because they will pull you up on the stand if there's a lawsuit that goes on, and they will ask you all kinds of questions about where those samples were when you were collecting them. Did you ever leave those samples outside of your view? Were the samples kept under lock and key? And that chain of custody actually starts when you receive the sample bottles. So, from the time that you receive those sample bottles to the time they arrive back at the laboratory, you would be responsible for them. Um, Basically, some guidelines are you want to keep the number of people that are handling samples down to a minimum. So, usually, you want to have just one person who's going to be in charge of handling the kits and collecting the samples. Um, on the paperwork, there's a document of transferring samples from one person to another, um, and you want to give these samples a data identification. Make sure you're actually writing legibly, and do not never want to use a pencil. You want to use permanent ink when you're writing anything on a chain of custody. This is just kind of an example of a chain of custody. You can kind of see like the client comments, the date and time collected, the sample site description's important, the sample type. Obviously, a lot of these are going to be drinking water, so you'd have a D in that column. The number of containers that you're submitting to the laboratory. So if it's a single bacteria, it's one container. If you're doing multiple samples, you want to make sure you include that. And then the test that you are requesting. And then on the bottom, you'll see where the person who is collecting the sample needs to sign, who ships it. If you relinquish those samples to another person, you need to sign, and then whoever receives the samples need to sign. This is what I'm kind of talking about in terms of chain of custody. So everybody sees exactly who was in possession of those samples. A lot of times, if you're out there doing a lot of sampling, and for a time there, I was doing quite a bit of sampling in the gas drilling boom that went on up in Pennsylvania and here in Ohio. You want to keep a field sampling notebook. This is a good idea. Don't rely on your memory. um, I would keep a notebook where I would keep date and time collected, the depth of the well, make sure I'm the one who's collecting it. If there are other individuals there, like uh, observing it, make sure that you noted that. Uh, Note where the sample was collected, whether it was pre-filtration, post-filtration, if there was filtration at all, what the source was. A lot of times there was GPS coordinates if you had them available. Also, a good thing to note is if you notice anything about the water quality, there was a different color, it was stinky water. One of the good things about technology nowadays is we've all got cell phones. Take a picture of where you're collecting the sample from. Document everything, especially if you're looking at potentially having water results being used in litigation. Another good thing to keep in your notebook would be any field measurements that you do. So if you're measuring pH or chlorine or conductivity, turbidity, any of these on-site tests that you're doing, make sure you note that. And then I also would keep track of all my calibrations in these field for any of my field equipment. So anytime I would calibrate my pH meter or my conductivity meter, I would make sure I note that, because when you're on the stand and they're asking you questions about when you collected the sample, you want to be able to refer back and say, do you remember when you calibrated the pH meter prior to collecting the sample? Most of us are not going to probably remember that off the top of our heads. I know I definitely would not. So that's why it's important to write these things down. Again, this is more so when you're dealing with uh, samples that are certified that could potentially go to litigation or are for regulatory requirements. The other thing is, we all make mistakes. When you're doing a correction on any of this paperwork, whether it's a chain of custody or in your field sampling notebook, there's a proper way to correct it. And that is to put one line through it and then make sure that you date and initial it and then make the correction. So, sampling locations. This is going to be dependent on the reason for testing. If you're testing for a public water supply requirement, they're probably going to dictate to you exactly where you're going to collect the samples from, whether it's the source where you're getting raw samples or it's within the distribution system. The regulations are going to spell that out for you. When you're doing private well testing, it may not be clear. This is where you want to talk to the homeowner and find out what's the testing for. Do we want to just find out what the quality is of the well water? And in that case, you want to collect your sample as close to the well as possible. Um, if not, maybe you want or if they want to determine whether they need water treatment equipment, you want to make sure you collect the sample as close to the well as possible. Um, if there's treatment equipment installed and they're having an issue, you might want to test after that equipment. So, a lot of times when you're testing private wells, you want to start talking to the customer and see what the actual problem is that they're experiencing, and then base your sample point on what your client's telling you. Informational testing is a great option when you're testing private wells, especially if you're trying to determine treatment needs or if treatment equipment is functioning properly. A lot of people will have equipment put in, but they say the water still tastes funny, or it still smells, or it looks discolored to me. That's where you might want to do a test after the treatment equipment. So, sample collection containers. A lot of times, this is a little bit more involved than just I'm going to collect a sample or I'm going to just fill up a bottle and send it into the lab. Sometimes it's that easy, sometimes it's not. But each method that's out there will actually spell out specifically what kind of container that you need to use, whether it's a plastic container, a glass container, if the container needs to be like an amber or opaque. Um, Again, the container size, um, that'll be driven by the type of analysis. Certain analysis will require so much water to run. Additionally, it could be regulation driven as well. Like, for example, lead and copper testing. When we do a test for lead and copper, we only need a couple of mils of water to run that analysis. But based on the lead and copper rule, they actually require you to collect a full liter of water. So sometimes it's regulation driven in terms of what size container you need to use. Different types of preservation are used in order to preserve the sample. Refrigeration or keeping the samples cool, so shipping samples on ice. Acidification's a big thing in terms of preserving samples, and then there's also other preservatives that are like dechlorinating agents and various other preservatives to help preserve the sample depending on what the analysis is that you're running. Some safety measures, make sure that you pack the glass bottles to minimize breakage. A lot of times when we send out samples, we send out small vials for testing VOCs. They're small 40 ml vials. These are the ones that tend to break. So we usually include them in like one of those little bubble bags. So when you're sending your samples back, make sure that you put them back in the protective bubble bags to make sure you're going to minimize that breaking. It's also important to wear like eye protection and gloves. Usually I'll use a nitrile glove when I'm collecting samples. This is not only to like protect the integrity of the sample, although it does do that, but it's also to protect yourselves because Some of the preservatives are either acidic or caustic, and it's not a good idea to get those on your hands or in your eyes. So it's important to take those types of safety measures. Um, you can review the material safety data sheets. Like I said, these preservatives could be acidic or caustic. This is just an example. Hydrochloric acid, we use this a lot when we're doing testing for volatile organics. So this is just something that you might want to review with people, especially if they're not familiar with the sampling protocols or somebody that's new to it. Just gives you an idea of some of the hazards that might be involved with these chemicals. A lot of times it's not a lot of hydrochloric that we're sending you. In fact, we don't like to send that out at all if we can help it, but certain analysis does require acidification in the field, so we can't avoid it in certain circumstances, but just make sure that you're aware of what you're being exposed to and take those safety precautions. Holding times. This refers to the amount of time the laboratory has from the time the sample is collected to the time the sample has to be run. So this is going to vary by method, analysis, regulations. Some of the more common short hold time parameters are like bacteria has like a 30-hour hold time. So depending on the type of bacteria you're running, like coliforms under the Safe Drinking Water Act, usually they'll give you 30 hours. But if you're running fecal coliforms under the Clean Water Act, sometimes they'll only give you 6 hours. So it depends on the state in terms of some of these and how lenient they're going to be. Um, but things like odor, color, they have a short hold time, 24 hours. Nitrate and nitrite, 48 hours. Phosphate, turbidity, 48 hours. And then your foaming agents. So kind of be aware of that. And usually labs will make you aware of that. When you're collecting those samples, you keep that in mind, especially if you have to ship samples to a lab, that you're collecting it late enough in the day so that by the time the sample arrives at the laboratory, they're still within that holding time. Trip blanks and method blanks. Trip blanks are basically laboratory grade water. So we use a DI water that um, is filled up in a bottle and it accompanies the sample throughout the whole sampling process. And basically, it's intended to determine if the sampling is contributing anything to the contaminants that might be found. So, like for example, volatile organics are a very common one that we use trip blanks for. So let's just say, you know, you take your samples and you decide you have them in the cooler in the back of your car or your truck, and you decide you're going to stop and get gas. And now you have VOCs in those vials. Well, that'll also be in your trip blank. So that trip blank will tell the lab that something in the sampling process is contributing these VOCs, and it may not necessarily be in the water. Method blanks are, again, it's laboratory grade water. It's treated as a sample, and it's the same thing, except it's looking for anything that's in the laboratory environment that might be contributing to the contamination. Labs use all kinds of chemicals. We have all kinds of preservatives that we use. We use all kinds of chemicals for extraction. Some of these chemicals are, VOCs that we would be testing for. So labs will run these method blanks along with samples to make sure that we're not contributing anything as well. So when you're testing for bacteria, there's a couple of things to look out for when you're looking for a good sampling point. Um, so which sink is better on this one to collect a sample? Well, the one on the left, the one with the light, is probably one of the worst places that you could collect a sample from. Number one, it's got the hold and cold and hot all on the same handle. and that is a great place for bacteria to grow. So that is strike one. Secondly, you see there's that pull down hose. Also, not a great place to collect a sample from. Bacteria love to grow in those hoses, and they're very hard to disinfect. Because when you're collecting a bacteria sample, you're going to remove the aerator from the bottom of the faucet, and you're going to clean the spigot with a like isopropyl alcohol or a chlorine solution. Those pull down faucets with the tubes, n- not the best. So if you have a choice when you're collecting a sample for micro, you want to look for a spigot that has both a hot and cold tap separate. And you want to be able to remove that aerator or strainer from the bottom of the spigot. And you want to be able to disinfect that using an alcohol swab or some sort of chlorine solution. You want to check with your state because certain states have specific requirements on this. Some states say you can't use isopropyl alcohol and you must use chlorine solution. Some states say isopropyl alcohol is okay, go ahead and use it. So one of the big things about micro testing is you'll get a bottle with micro testing and it will be a sealed bottle. That means, the sample bottle has integrity. If you get a bottle where the seal is broken, I don't recommend using it. I would definitely call the laboratory and have a replacement bottle sent. When you're collecting the sample, you want to take care with this bottle. Do not touch the inside of the cap or the bottle anywhere around the rim. Do not set the cap down. Um, Especially, I try not to set it down at all, but if you're going to, you want to make sure that the inner part of it is set up because you could inadvertently contaminate your own sample. Again, we're going to remove that strainer or aerator or any type of filtration device that might be on the edge of the faucet. Disinfect that spigot using whatever solution is approved in your state. You're going to allow that water to run 2 to 3 minutes. Usually, you want to I usually just make sure that when the water becomes like cold and consistent in terms of temperature. So, usually that's about 2 to 3 minutes. It may be a little longer. And then once you have the sample collected, you're going to fill up the bottle, and bacteria bottles usually have a fill line on them to where you need to fill up the sample to. You want to usually leave a little bit of headspace at the top. These are not bottles that you fill all the way up. Once you have those samples collected, you're going to put them on ice. I recommend usually using a cooler. Some labs will provide like frozen ice packs that you freeze at least 8 hours before you collect your samples. Some labs have you add wet ice. Um, the temperature requirement is that these micro samples need to be received at the laboratory within 10 degrees Celsius. Now, if you're dropping samples off at the laboratory, obviously you might collect the sample and it might not be at 10 degrees by the time you get there um, because you haven't had time to cool it off. But if you are dropping off, make sure that you still have that sample on ice because the requirement is if you're dropping it off, you have to show that you're attempting to cool that sample down. And again, with the coliform testing, and depending on, like I said, your state and your requirements and what bacteria you're testing for, usually it's 30 hours for coliform under the Safe Drinking Water Act. Get those samples to the lab within that time frame in order for them to start running it and meet that holding time requirement. Inorganic chemicals, metals, there's different types of sampling locations. You may have somebody who is concerned about lead in a particular area of their house. Again, this is where you want to listen to your customers and what their concerns are. We did talk about container size. A lot of times that could be regulation dependent or depending on what it is that you're testing for. Again, plumbing can contribute to that detection, especially when we're talking about lead and copper and zinc. Metals have a much longer holding time. depending on if they're acidified or non-acidified. So when we're talking about metals analysis, usually we acidify using nitric acid. Um, if the samples are collected and they're acidified, you have 6 months that the laboratory can have those samples and hold them and run them 6 months later and still be within the requirement of the method. If the samples are non-acidified, and a lot of labs do not like to send out bottles that are acidified because we don't like acid in the hands of people that are not familiar with it. And like I said, there's safety involved depending on who's collecting these samples. We have 14 days to get the sample to the lab, and then we can acidify it in the lab. And then once it's acidified, it's good for the 6 months. With metals, there's no refrigeration requirements. So if you're collecting samples for lead and copper, um, you don't have to keep those on ice. You can ship them, room temperature or whatever temperature they're at. In terms of collecting these samples, it's mostly plastic bottles, except silica. Silicas actually should be collected in a plastic bottle um, because it's found in glass. So I'm not sure why I have that in there. Um, Other inorganic compounds, so things like nitrates, chloride, fluoride, sulfate, some of those have those shorter holding times, like nitrates, for example, and they do have some refrigeration requirements. A lot of those requirements will have those compounds, they have to be received at the lab between 4 and 6 degrees Celsius. So, especially if you're collecting in the summertime, um, when it's really hot out, and depending on where you are in the country and where the lab is, you might have to chill those samples before you ship them out. And so, what I used to do is I would, if I'm collecting in the summertime and it's, 90 degrees out, you have a cooler full of ice, and I give those samples an ice bath. I let them sit in the ice for several hours before I ship them. So, it's very it's kind of like a little bit of a tightrope act that you're doing because you want to meet that holding time. So you gotta keep that in mind. But you also have to have the samples chilled enough so that when they arrive at the laboratory, they're within the temperature requirements. So, it's you have to think ahead and you have to plan for this sort of thing. Organic sampling, a lot of times volatiles, we use 40 mil vials, so they're we call them VOA vials. Headspace with these. These are the ones that they ask you to fill so that they're slightly overfilled, and then you cap them, you turn them upside down, and see if there's any bubbles in there. You don't want to have any bubbles in your volatiles. You don't want to have what we call headspace. So we don't want any air in these samples. There's a special cap that's used to basically try to keep any volatiles that might be in there from escaping. So if there's a bubble, there is a possibility that those volatiles could go into that air bubble, and you may not see the volatile when you run the analysis. Now, these sample bottles are a little tricky because a lot of times they'll require acidification in the field. There's already a preservative in there to prevent microbial growth. So you have to fill it up about halfway. You have to add the acid. You have to fill it so it's slightly overfilled, but don't overfill it and lose any of that preservation in there. And then cap it and make sure that there's no air bubbles in there. I feel like these, well, until we started testing for PFAS, I felt like these are the hardest samples to collect because they need to arrive at the laboratory with a pH of less than 2. They have to have, they have to arrive within that temperature requirement of 4 to 6 degrees. So when you're collecting them, it's very important to like get the water flow slow enough so that you don't overfill the bottle and lose any of that preservation. Um, Again, we kind of talked about trip lengths with these. A lot of times labs will include those trip lengths. Um, if you're doing this type of testing, you probably want to talk to the lab and make sure that you're not paying extra for those trip lengths, because some labs will charge you extra for them. Um, they have a 14-day holding time for it. So you've got 14 days, but keep in mind that whole temperature requirement. And that's why you have to ship these sort of samples overnight. And then we've got other types of synthetic organics. These are usually like pesticides, herbicides, that sort of thing. Again, depending on the method that you're running, the method will spell out exactly how you have to collect these samples. Some of them require this extra field acidification. Um, there's headspace issues with some of them as well. Some will require a much larger sample. A lot of times they're like 1 liter glass ambers for certain pesticides. And then the holding times can be a little bit different for these. Um, so there's like a holding time from the time that they have to extract it. So you might have 14 days till you have to extract that sample. And then once it's extracted, you have another 28 days to run that sample. And it differs based on whatever method it is that is being run. So a lot of times people will get excited, they ship these samples overnight. It's been 2 weeks. Why don't I have results? I spent all that money on overnight shipping. The samples are no good anymore. When in fact, that's not necessarily true. We have time in terms of that. So I did say VOCs were probably the hardest to collect, and that was until PFAS came along. Um, PFAS contaminants are a little bit harder to test for. There has to be quite a bit of planning involved with these tests. Um, there's a lot of instructions, a lot of things you can and can't do. So the first thing you want to do is determine where the samples are going to be collected. If you know where they're going to be collected, um, this will give you an idea of whether field reagent blanks are necessary. So, like for example, if you're going to collect a sample from an outside tap and it's right next to um, a deck that's been treated for water resistance, you probably want to have a field reagent blank. That's to ensure that whatever's in that, whatever possible PFAS that could be on that deck is not contributing to what's in your possible sample. You also have to plan your field equipment. A lot of times I would use Teflon tubing to collect samples, as it was probably the most inert place to collect samples and not contribute other contaminants. Can't be using Teflon at all when you're doing any sort of PFAS testing. And then people don't realize how much PFAS is in our environment and how much we actually use. So, I mean, you have to prepare your proper clothing. So, just a couple rule of thumbs, no new clothing. Preferably want to use washed cotton that has been washed several times without any sort of softener. Nothing that's going to be water resistant, waterproof, or stain treated. So, a lot of times this is hard. When I did my first test, it was really hard to actually get dressed, because you want your North Face, you want your boots that have been treated for waterproof. None of that. You can't have any of that. So other things to avoid: cosmetics. I'm sure you guys use lots of that. Um, Moisturizers, hand creams, anything like that. You want to avoid that on the day of sampling. If you're going to be out in the sun or the elements where you might be needing sunscreen or insect repellent, it's best to choose something that's going to be all natural or organic. Um, PFAS is in a lot of different things, so you want to make sure that you're not contributing to it by what you're wearing or what you've put on your skin. You want to use sample bottles. Only use the bottles that the laboratory provides. Usually these bottles and caps are going to be a HDPE or a polypropylene material. Again, I kind of mentioned no Teflon containing materials, the tubing, Teflon tape. I know these are some of the things that you might keep in your vehicle. When you're sampling for PFAS, make sure that you remove these. No waterproof field books. Remember my field notebook? I have to have a whole separate one just for PFAS. No clipboards, no binders, no spiral notebooks, no post-it notes. Do not use blue ice packs. When you're testing for PFAS, they they tell you to use wet ice that's preferably known to not contain PFAS. So when I first did my first sample, I was like, well, how do I know that my city doesn't have PFAS in the water? Well, I don't. So, I mean, I went to the extent of purchasing RO water and making my own ice. I don't think you need to go to that extent. What we've kind of done is provide additional Ziploc bags to double bag your samples so that any ice the sample could be coming into contact with is not getting into your bottle. The other thing is if you're testing for volatile organics and PFAS at the same time, you want to keep those kits separate. The volatile organics bottles use a special, I mentioned the special cap that they use. Well, there's Teflon in that. So you want to make sure that you keep those sample bottles separate if you're sampling them at the same time. You want to use nitrile gloves when you're collecting these samples, especially if you might have used any sort of lotions or anything like that on your hands. Only water or hydration drinks in the staging area. So no food, drink, anything like that while you're collecting these samples. It's good practice to wash your hands thoroughly before you collect your samples, whether it's PFAS or any samples. The powderless nitrile gloves. When I'm collecting samples, depending on how many things I'm testing for, so like if I'm collecting VOCs, PFAS, inorganics, I'm going to switch my gloves out between each sample bottle. Um, Especially like when you're collecting micro versus PFAS, you probably want to switch your nitrile gloves out. Again, double bag those samples um, to avoid that possible cross contamination with the ice. Now, field reagent blanks and trip blanks are a little bit different. Now, we talked about the trip blanks that go along, they're just a filled vial. You don't actually do anything with them. But a field reagent blank is a lot different. A field reagent blank for PFAS, they actually send you two bottles. One is empty and one is filled with laboratory grade DI water. And before you collect your PFAS sample, you're going to collect your field reagent blank. And what they do is they actually have you open up the bottle and pour it into that empty bottle. So you're getting much more of an exposure in terms of that environment. So if there's PFAS present in that sample, they can go back and look at your field reagent blank to see if there's anything that is in the area that might be contributing to it. Again, they also use trip blanks as well. When you're doing a lot of these samples for some of these high profile contamination sites, they will include trip blanks and field reagent blanks. The sample requirements for this is once you collect these, once you fill up the bottle, it's a 250 ml bottle that you're going to fill up. It has a preservative in there. You want to make sure you agitate that bottle after you collect it just to help dissolve that preservative that's in there. Again, when you're collecting these samples, do not set that bottle cap down as you could potentially contaminate that sample. Again, I said it was a 250 ml bottle that we're using. The preservation that they use is Trizema. It's a buffering reagent, helps reduce the chlorine. For PFAS, this is under the method, the most common method out there right now is 537.1. The holding time, we've got 14 days to extract that sample. And then during that 14 days, we have to keep it at a certain temperature. It has to be at that 10 degrees Celsius. And then once we extract it, we have an additional 28 days from the time we extract it in order to run it. And what's nice about that is we can store them at room temperature. I'm not sure if everyone knows at laboratories, there's lots of temperature requirements. We have lots of refrigeration. We have lots of requirements in terms of documenting what those temperature requirements are. So our refrigerators are checked every day for temperature. Somebody has to sign off on it, and it's entered into a record. So like when we get audited by the state, they come in and take a look, make sure that we haven't gone outside those temperature requirements. So temperature preservation is very important, especially with the PFAS. They require it to be kept at that 10 degrees for at least the first 48 hours. Again, I kind of mentioned the temperature checks at the lab. And then we have to store it at or below that 6 degrees until we extract it. So reporting and results. So the Safe Drinking Water Act kind of tells us exactly what we should be testing for, or the bottles that we use and the preservative. And then the units of measurement. A lot of testing that we do is in like milligrams per liter or parts per million. We're used to that in terms of reporting for metals. Some we report down to the part per billion range, um, or the microgram per liter. With the PFAS coming out, we're now looking at more like part per trillion range or nanogram per liter. So we're starting to look at much, much lower levels. And then as along with everything else, there's what we call like matrix interference. And that's basically the matrix of your water. There could be something in that water that interferes with us running our tests. Um, so how we determine that is we take a look at the analysis, and we're required to spike a random sample. So say we have 10 samples, we're running it for VOCs. We randomly spike one sample with a compound that we're not necessarily looking for, but what we sort of it's like a standard for us, and then we test for it. And then depending on how much of that we're able to recover determines whether there's matrix interference. So let's say we spike it with something like, just for example, benzene, and we only are able to recover 50% of the benzene that we spiked it with. We know that there's something in that water that's interfering with our analysis. And so that's what we have to go back and either figure out how to alleviate that interference if it's a known interference, or we may not be able to alleviate it and we have to go back out and collect another sample. So matrix interference is very problematic with certain analysis. Shipping samples. If you're shipping samples out to laboratories, a lot of times they will provide you with coolers to help you maintain that temperature. Sometimes they'll include ice packs or they'll instruct you to use wet ice. Um, Notice here that I don't recommend using those ice packs when you're sampling for PFAS, as some of those can contain it. But samples still need to be kept cool. So you want to make sure that you pack them with wet ice. Like I said, in the summertime when it's extremely hot, you want to make sure that you give those samples an ice bath so that they arrive at the laboratory within that temperature, because there's nothing worse than, driving 2 hours to a sample collection place and then finding out that you have to go back and recollect. Um, Again, timing, make sure that when you're sampling that the holding times are going to be met. So if you're collecting micro samples and you have to ship them, you probably don't want to collect them first thing in the morning. You want to collect them later in the afternoon so that when you ship them and they arrive at the laboratory, they're still well within that holding time. Because even if the sample gets there with, let's say it gets there in 30 hours, the lab still has to process it. So the lab has to do a lot of different checks when the sample comes in to make sure it's in proper condition before they can actually start running it. So if it arrives on hour 30, by the time they actually get it set up to run, it could potentially be out of hold time. So just some things to keep in mind when you're sampling, different holding times. A lot of labs will give you instruction on how to do this. We recommend collecting after 1 o'clock Eastern time to ensure that the samples get to us in plenty of time. And I believe that's all I have. Does anybody have any questions? Well,
Feel free to unmute if you'd like to ask a question. There's it's a small enough group. You can unmute yourself if there is.
Yeah, I can't think of anything to ask right now, but I think the presentation was great. It was spot on, a lot of good information.
oh, thank you. If anybody has questions, my email's up there. If you think of something or if you run into an issue, you have questions about something, feel free to reach out. I'm a resource for you guys.
Well, thank you. This is being recorded, so I will look at the recording and make sure it's appropriate for us to upload to our YouTube channel. And if it is, we'll provide it as a resource for others moving forward. And thank you, Marianne, for presenting and for allowing us to record and have it as a resource for our contractors moving forward. And I will make sure your information is out there as well if they need to contact you.
Great. Thanks. Thanks for having me.
All right. Thank you all. Have a good day.